Okay, so we've got our tic-tac-toe and our checkers game. I'm going to ignore checkers for now and just focus on tic-tac-toe. Actually, what we're going to worry about is the board specifically. So the tic-tac-toe game is kind of a board game, and it's got a tic-tac-toe player, right? So it's a board game that plays with tic-tac-toe players. We've got our two players, X and O, and we can tell if it's randomly over. So we won't worry about that just yet. We're going to go to our board. So our board is think about a chessboard, a checkers board, a Monopoly board. A tic-tac-toe board is just a 3x3 square, right? A set of squares. Those squares in our place is literally called square. So squares have a piece on them. And you'll remember that mostly I normally make things final. But in this case, I intellectually know that I'm going to move pieces from one square to another. Or a piece may not have a square. In the case of tic-tac-toe, a piece may not have a square, and then it'll be put onto a square. And a square won't have a piece. And there's a relationship there. This piece knows which square it's on, and the square knows which piece it is on. One problem here, you'll notice there's an issue, and if you remember, piece belongs to a kind of player, right? So we're actually just going to steal this. Because we need to be able to say that that belongs to that. Of course, that doesn't know where that comes from, so I have to put that there, and we can get rid of that part, right? So now this is a piece that belongs to a tic-tac-toe player, and it has that particular kind of symbol, so string or color, whatever. Right? So we could have just said piece, but we wouldn't have the type safety. So now every time we look at piece, we can think of this whole thing here as tic-tac-toe piece or checkers piece. That's the way I like to view it. So squares have nothing to do, right? This is the constructor we could create. Remember that that is the same as the default constructor. If that's the default constructor, we can just not provide it at all. We might decide, actually, that and remember, you would never actually type super. We might decide that we want to be able to start a and again, whenever you use it, sorry, I need the whole thing, just that. Because we don't have to say extends whatever, because it's already set up here. When we say p extends player, every time we see p, it knows that it's extending player. So we could decide that we want to have a square start off with a piece, right? And that's awesome for some games, because chess, think about chess, for example. You start off with some squares having a piece, some squares not having a piece. So we could provide two constructors, one where you give it nothing, piece will be null, and one where you give it a piece. You can choose to do that or not. I'm going to choose not to, because what I'm going to provide anyways is a public void set piece. And it's going to say piece assigned p. Now again, I need to decide, am I going to handle null, right? Is it allowed to have a null piece? Well, setting a null piece would be removing the piece from the board. So think about chess or checkers. You move it from one square to another. In the case of tic-tac-toe, we wouldn't allow them to do that, right? So piece could not be null. But the general rule right now is that piece can be null. But now that I think about that for a second, I'm going to make this an abstract class. Actually, no, I'm not going to make an abstract class. I'm going to show you a different way of doing things. So I'm going to say, I'm going to make this thing. Let me finish the get method first. And yeah, you have to provide these parameters all the time. So sometimes you want to subclass, other times you don't subclass, you do it a different way. And some languages do this more than others. What I'm going to show you is quite popular in Swift, and there's no reason it wouldn't be popular in Java. But quite often in Java, we would just subclass and make a TicTacToe square. But there's another way around it that we don't have to subclass. So sometimes I want this to have this be null. The other time I don't want to have it be null, and it could be on a game. You could imagine a game where pieces aren't allowed to go at all, or only a certain kind of piece can go on a particular kind of square. So I want to, rather than subclass to get that behavior, I'm going to use an interface, and I'm going to have a checker that can go. So what I'm saying is I'm going to have this thing called a checker, and I'm going to see if this piece can go onto this square. So in order to do that, I need a private move checker, we'll call it. Checker, and if I'm going to call it checker and it's move checker, I may as well call it move checker. So now I need a class called moveChecker. And it's probably actually an interface. That'd be my presumption of creating one of these things. And this is actually something called the command pattern. You can look that one up. And I will need to borrow this because I'm lazy. So this move checker checks that a tic-tac-toe piece can go on a square that holds tic-tac-toe pieces. So again, how I would read that. And it's going to return a Boolean. And it's just telling us here that the return value is never used. That's because I didn't think of that when I started creating this. So we're going back to square. So if I can't do this, I'm going to throw an invalid move exception. Now I might decide, invalid move exception is just going to extend from exception, but actually I could probably think that there's a whole bunch of different exceptions that go on in the game. So I'm going to make a new Java class for game exception. And I'm going to say, because I like to do this, that anything that extends from game exception has to provide a message, because those messages are really valuable. So invalid move exception will now extend the game exception. And it's unhappy because we're not calling the constructor with arguments. So I want to say something like cannot move the piece to the square. Okay, so I can't move the piece to the square. So that means I'm going to have to pass in a change those to P and S. There's a reason for that. I'll get to it in a second. I don't know if I've ever actually tried to make a generic exception before. This is a new one for me. So I'm going to just punt for now. I will actually go back and look up how to do that, if there's a right way to do that later on. Every so often I wind up doing something new. And I'm going to make a private piece final. So getting the message is great. It does let you print something out to the user, but quite often that's not something you do want to print out to the user. So what I want to do is give, and I'll be lazy here. What I want to do is give the programmer the ability to easily get the values so that they can build their own message. So now square is unhappy because, well, first off, we're not passing in the piece and the square. Now it's unhappy that we're not throwing the invalid move exception. And it's actually probably unhappy because I don't have enough things there. And I'm not saying new. There we go. So I guessed at all the things that were not true about why it was unhappy. But it does have to add the throws because this is a checked exception, because invalid move exception extends from game exception, and game exception extends from exception, and game exception is a checked exception. Therefore, game exception and invalid move exception are checked exceptions too. So now what we have is, this can be final, and this is going to have to be a P and an S as well. So that's happy. So why is this unhappy? Think if you pause the video, see if you can figure out why you think it's unhappy. When you come back, I'll give you the answer. So pause. And the answer is because we're not initializing move checker in the constructor. And now it's happy. So that means every square has to have a move checker. We may not want that. So what I'm going to do is I'm going to provide a particular implementation here of our class that implements move checker, and it's going to be unhappy. Why is it going to be unhappy? Pause the video, see if we can figure it out. When you unpause it, I'll tell you the answer, so pause. And it's because move checker has methods that you have to implement because we're a concrete class. So the default move checker, and I'm just going to make this final because it doesn't make sense to extend it. It's only got one method. If you're going to override that method, you should just be implementing the interface. There's no benefit to doing that. And again, I want to be lazy. Move checkers require the generics and pass the generic on to the parent. And this is a P and an S, and this is a P and an S, and return true. So by default, we're just going to say any piece can move to any square. Doesn't matter. But we might have another one. And actually, we will need one for TicTacToe, because what does TicTacToe have to check for? And it's move checker, right? How do you know if a all the generics. Always got to put those in. So how do you know if a piece can move to a particular square in TicTacToe? Well, in order for that to be true, the square can't already have a piece on it, right? So the pieces get piece would have to return false. I might want to actually add a couple of convenient, or at least one convenience method to see if the square is empty. That will just return piece equal to null. Right? So if the piece is null, it'll return true. The thing's empty. Right? If I really want, that's all I have to provide. I might choose to provide is occupied and have that piece not equal to null. That totally depends on your use cases and how you want to say things. And are you going to use is empty more? Are you going to use is occupied more? Do you want to call not is empty? Do you want to call not is occupied? So I'm going to leave this here because why not? You probably reasonably expect to for any particular game to want to check if it's empty or if it's occupied. But if it was really, I always check is empty, then I wouldn't bother with it. But it's not that much code. It's one line, right? And again, what I should be doing is also unit testing. Remember that, right? So I'm not unit testing right now because I don't want to interrupt the flow of the thought process here for you. But really, when I'm doing this, it should be unit testing. I should think, okay, I want that method, have it throw an exception, go write the unit test, and then write the code to pass the unit tests. So that's about it. That's a square. So then we have the board. So the board is made up of squares, right? So I'm going to grab this because I know I'm going to need it. So board, private, so this winds up being a little bit fun, and it's going to show one flaw about generics in Java. So our board is made up of a bunch of squares. I'm going to make this a abstract class. No, I'm going to make an abstract class. My thought process is, do I want to make a tic-tac-toe board versus a chessboard versus a checkerboard? But I think I'm not going to bother with that yet anyway, so I might change my mind later. So how many rows and how many columns? What's the width? What's the height? However you want to consider your board. So squares is assigned a new square of P and S. Don't normally initialize variables this way. So let's see. Rows. Okay, so it's unhappy about something. And it's unhappy about a generic array creation. I'm not going to dig into why it's unhappy about this for now. I'm going to show you how to fix it. I will do a separate thing that deals with that. Okay, maybe I'm not. Let's just see what happens here. I could just be happy with that. Yeah. I'll do a whole separate thing on generic array creation. It's something I desperately try to avoid. So I'm not remembering off the top of my head how to deal with it, and I just don't want to switch to the browser right now. But I'll make a separate video that talks about it. It's It won't be long, or maybe just a set of slides. It's not a hard thing. But I want to go read up on the rationale behind the whole screwed upness. But yeah, when you're trying to deal with generics and arrays, it doesn't work the way you would like. So we've made an array that holds a row number of squares. And now we're going to go, I'll call this row instead. And now we're going to make, for each of those, not an int, sorry, it's a square P S array of those. Call, sorry, old habits. My day we would have called them I and J, but row and column seem much more better. So what we have here is an array of arrays. Oh, I see what's wrong. There should be squares. Oh, okay. My mistake. One minor thing. There we go. This should be an array of arrays. So, trying to do this without drawing. Think of a chessboard, right? So you've got an 8x8 grid. So that's 8 rows of 8 columns. So 8 rows of 8 columns. So here we're making 8 rows that will hold some amount of other columns. And here we're making 8 columns. And we're saying that for the first row, we're going to take these columns. For the next row, we're going to take these columns. Next row, right? So it's an 8x8. And then for each row and column, we're going to put in a square. So we will now have 64 squares. If you think of our TicTacToe board, we're going to have 3x3, right? So we're going to wind up with 9 squares, right? 3 squares in one row, 3 squares in the next row, 3 squares in the next row. And we created our square with no constructor, calling the no constructor, and that made a default move checker. But that's not what we want, actually. What we want is to pass in a move checker. So this constructor also needs to take a move checker. You can call it move checker, doesn't matter. And at some point in time, somebody had asked about using composition sort of thing instead of inheritance. This is kind of sort of probably what was being talked about, right? So we didn't extend from the square. We made another class. There's inheritance involved in that class, but it's much smaller. So the square is composed of a move checker instead of having a subclass that deals with it. So it's likely what the question was really about, or the answer to that question, or the rationale of the company. So now we've created 64, in our case for TicTacToe, 9 squares that all deal with the appropriate move checking. And then we probably want public square a method to get the square at a particular row and column. I don't know why I continually screw that one up. Oh, and it caught me. So here we're going to say not making a new one, sorry. We're going to get it from squares, row, col. Now, I have to make a choice for a couple of things. First off, what can go wrong? Let's move back for a second. What can go wrong in our constructor that I forgot here? I forgot to deal with the move checker. If the checker is null, I don't want that because this would then have a null pointer exception. So we're not letting you pass in a null one. We use the default for that. So there's always a checker that can do whatever it wants, right? This one always returns, yeah, sure, let the piece go there, but I don't ever have to check for null. Not null pointer exception. So when I threw the illegal argument, it meant we couldn't construct a square that has null for the checker, therefore this line can never be null. It's impossible. So that's yay. The piece we decided it can be null, doesn't matter, so it's just the checker we have to check. And then in the board, what can go wrong here? So there is stuff that can go wrong. I'm gonna pause the video and you can tell me, or you can think for yourself about what you think we should check for. So pause, and I'll answer when we get back. Okay, so if the rows is less than or equal to 0, right? We can't have rows less than or equal to 0. Throw new legal argument exception saying that and the same with the columns. You have to at least have a 1-by-1 game. And we could check the move checker being null here, or we could let the move checker get caught by the other one. Your choice, honestly. I'm going to let it slide because the first one that it gets to here will throw a null pointer exception. Or, I mean, an illegal argument exception. You do, though, go through the process of creating some memory and all that that's just going to be thrown away. So if we did want to say, if we did want to say, no, we want to be sure, we could do this. And then we don't do any creation. So this becomes a judgment call for you. But you'll notice that, I do all my error checking first, and then once I've done my error checking, I do the rest of my code. So it's a good habit to get into. Here, there's no point in me checking the row and column for being invalid because it's going to throw an array and index out of bounds exception. I might choose to decide to say that that's a checked exception, though, and make my own subclass of game exception that says invalid, row invalid height or column. Your choice. it doesn't matter. I mean, it matters, but there's no right or wrong answer. It's a case-by-case basis. So I can't just tell you, well, that's what you should do. So you have to decide for yourself. My decision is I'll just let the array index out of bounds happen. So now we have a board that can be 1 by 1 or greater. And that board is contained of squares, and those squares can contain pieces. Like I said, it's also useful for a... I'm going to make things private by default for a piece to know what square it's on. Oh, here, something we never checked. Oh no, I think, no, we didn't. So it's, now why did I call this P? Oh, P for player. Let me change it to O for owner. So it's never too late to add error checking in as you notice things were incorrect. Right, so every piece has to have an actual owner. It can't be null. That might not be true. Maybe the system owns pieces. In that case, it'd make some sort of special system player and just have that player own all the pieces. So here I'm going to, and notice that it's not, I'm not going to go to, I'm going to generate. Notice that this isn't final because players can move from one square to another. Not in all games, but it is a general rule. So this will be a getter and setter for square. And the question you have to ask yourself again is, can square be null? So can you set a square to null for a piece? And yes, you can, because think about a game of chess. The pawn takes the queen. The queen now is not a square anymore, so their square would be set to null. So now we have the ability to have a board that's got squares. Squares can have pieces, and pieces know what squares they're on. So we're pretty close. Let's see what happens here. So a board game probably also needs a board. Now that board is going to be the same thing. Right, so now we had to add the S because once we use the board, we're going to have to specify the S for the symbol, right? And if I look at player, I just want to double check something. Yeah, player is good. No generics there. So the board game has a board. That's really final. Final tells me I haven't initialized the variable, so I need to come in here. Now I have to make a decision. Am I going to pass the board in? Am I going to create the board in here? Can't. I'm hemming and hawing because there's so many right answers and so many wrong answers, and they're both kind of the same. This is again one of those decision things. I'm going to say that we'll pass the board in. My alternative is to specify the rows and columns for the board. So now my thought process is, could that board be reused by another game? And it really can't be reused by another game. I couldn't give the same board to two games at the same time, because now two people are playing one game on the board and another two people are playing a different game on the board, and it'd be very confusing. So given that you can't specify what board, or sorry, that you can't have a board be used in two games at the same time, it really makes me want to have the board game create the board. So to create a board, I need rows, columns, and a move checker. So the problem is that, why I'm a little unhappy, is that this class now, the constructor, is going to start ballooning with a lot of things. But on the other hand, these all make sense, right? A board game needs some players, and we're still dealing with 2 players, and we'll change that later. It's got a board that has rows, columns, and a move checker. So it's not an unreasonable thing, right? The board constructor might be quite large, so I guess we can go with that. This is an advantage. So if I'd made a chess game or a checkers game or a tic-tac-toe game, sorry, if I'd made a board for each of those instead of just having a generic board class, then the board game couldn't create the board in here, because how could it know to create a tic-tac-toe board versus a chess board versus a checkerboard? So you'd have to defer that down to the game itself to create it. And then you'd have 3 places where you're creating the board. Here we only have 1 place for creating the board. So I do like that. So now our game has a board, and it's got a current player and all that. So that's good. Our tic-tac-toe game is going to be played with a 3 by 3 board. And we're going to pass it a new tic-tac. So I could create a tic-tac-toe board checker, a move checker, but I'm not going to do that. I'm going to realize that there's a couple of move checkers, and I'll be lazy. I'm going to take the default move one. There's a couple of move checkers that probably exist. The default one, which I'm actually going to rename, because it doesn't make sense when I make this one. Empty square move checker, so it has to move to an empty square. So if the square I think P also takes an S. So if the square piece is the piece on the square, or I could, okay, so I could just say, that's why I have that is empty is occupied thing. Now, you're probably going like, why didn't it just return is empty? Because in the debugger, I can put my mouse over is empty and it'll tell me if it's true or false, which makes my life a little easier when debugging things. So I always make temporary variables and return it, even for something this simple. So what you would write in 1 line, probably, I will take 3, plus 2 empty spaces. But my debugging process becomes so much quicker. So that's an empty square move checker. And I'm going to change this to a permissive move checker, which just means it'll let anything go anywhere. So you can think about chess is different, right? The piece has to be empty, or it has to not belong to your color. There's a lot more checking inside of a chess game on if the move is valid. Like, is it moving diagonally? Is it moving horizontally, vertically, that kind of thing? Is it moving 2 spaces? You know, can it attack that piece? Blah blah blah. Is that going to make it so your king is exposed and put you into checkmate? So there's a lot more move checking that goes on in chess than here. But just having an empty square move checker, that's not specific to TicTacToe. You can imagine other games where you can move there only if the square is empty. So this is a good example of that. So we will make a new empty square move checker. Oh. String, I think. And I made a mistake with the board game. Did I? No, not the board game. Unchecked tile board game. I'll get there. I'll figure it out. Let's close this all. Rebuild. Wrong number of arguments. There we are. Checkers player now needs to also take a color, I believe. So the checkers game has, I believe it's an 8 by 8 board, and we'll just go with the permissive checker for now. Okay, it's happy. Good. Yay. So now the thing to do is go back to our game, and we have this turn thing that we're not using. And we already know that this works. Right with that. So we have the turn thing that we're not making use of and all that. So what we need to do is say that we want the game. And we're in the game, right? This is a game. I'm going to say take turn. And I guess we're probably passing the current player and their turn. So what I might want to do in the take turn method is have something that recorded what the turn was. So I just want to maintain a history of what things were played. That way, say I want to undo moves, I can undo them and remember what this previous state of the board was. Right? I can return everything back to where it was. In other cases, when we take the turn in a board game, we're going to want to actually do the movement of the player in the board, right? So this is a private method, which means it can't be overwritten, because maybe I want to store the turn and then make the actual move. And that make the actual move is a specific thing for a game. right? So at least a board game is going to be different than World of Warcraft, for example, right? So what I'm going to do is I'm going to make another method, another abstract method here, and I'm going to call it do take turn. This is again an uncommon thing. So sometimes I get overzealous with my final. There's no point making final in an abstract method because there's no code in there to change it. So now we have do take turn. So we'll go to the board game. I didn't grab everything I wanted from there. So we'll go to the board game and take the do take turn to there. So what is a board game? All board games, how do they work? So if you think about an actual version of this where I have a nice UI and you use a mouse to select a square. So what'll happen is I'm a X player or whatever. I'm going to go into the top left corner. That's going to tell me that I want to go to put my piece in the square 0, 0, right? The top left corner. That's the first array. That's 0, and it's the first column in that array. So 0, 0. So somehow out of the turn, I need to be able to get information, right? I'm not going to do that right now. I'm just setting up for the next video. So I want to get the row and the column. I want to get the piece, and I want to put the piece on the square. So this is get square at the row and column. I want to get the piece and I want to put the piece in the square. So is that the same for tic-tac-toe as it is for chess and checkers? So in tic-tac-toe, I click on the square and I get the square and I put my piece, or somehow I get a piece and I put the piece on that square. Okay. Tic-tac-toe and tic-tac-toe checkers, I click on a square, it has to have a piece. It has to be my piece. So there's got to be logic in the game to handle that. And then I click on the place I want it to go. Presumably I'm going to also validate all that stuff at that point in time too. So that's fine. That'll mean that the turn needs to have the starting row and column and the ending row and column for a chess game and a checkers game, but not for a tic-tac-toe game. So this turn class is going to wind up being subclassing, right? Because we're going to have a tic-tac-toe turn, totally different than a chess and checkers turns, right? Tic-tac-toe only needs their own column. Checkers needs 2 rows, 2 columns, the starting and ending points. So we're going to have to, turn is going to be abstract, ultimately, or an interface. And the logic here also doesn't belong in here. So this will not go in board game. This will actually go in tic-tac-toe game. So that becomes a tic-tac-toe player instead, right? No generic needed. So the tic-tac-toe player is going to be completely different than the checkers game, which will take a checkers player, but that's not why it's different. But it's going to say get the square, get the piece, get the square at row 2 and column 2, move the piece to the piece from first to second square, right? So two totally different algorithm type things. The question that I'm going to ponder before I make the next video is, how does all that validation of stuff come up and everything? So yeah, I think we're a little more closer to our game actually being real. And notice I only had to make one little couple of changes to the I had to add the TicTacToe game here. I had to set up the board here, and I think I had to add this here, right? And the same for checkers. So really, add a few lines here, add some method for some logic that's specific to the game that we were missing. I haven't had to do much. What'll be really cool is when we get to making the GUI for it, because the GUI is just going to display a board. We don't have to have a TicTacToe GUI and a checkers GUI, because it's just a GUI that displays a board. How we interact to get the turn, right? Do I click on one place to make a turn in TicTacToe? Do I click on two places to make a turn in checkers or chess? And maybe there's games where I have to click in 10 places, who knows? But that getting the turn will be a different part of the GUI. So I'll have to figure out how to abstract that too. But yeah, so this is just building up the stuff piece at a time, right? Or step at a time. We started with the very lowest level. We made a higher level thing of the game to get that kind of working, and now we're back to somewhat a low level of the board. But we're getting closer and closer to the actual game logic. And at the end, we should be able to make a checker. If we do the TicTacToe game and we were to do the checkers game, and I don't think we will, but if we were to do both of those, making a chess game would be trivial, right? What we'll probably wind up doing is making a chess game show up and show all the pieces. But we'll see where we get to. Alrighty.